Hi, this is Mr. Snyder with Truman Middle School, and this lesson is about angles and triangles. Our objective today is to find unknown angles in triangles. So here we go. The only vocabulary we really need to know today involves the different types of ways to classify triangles by their angles and by their sides. Most of these terms, of course, you'll be familiar with. The one I would suspect you would not be familiar with is the Triangle Sum Theorem, and we'll talk about that in just a moment. The theorem kind of is based on the fact that if you tear two corners off a triangle and place them next to the third corner, the three angles seem to form a straight line. And as we learned with supplementary angles and a straight line, we know that that equals 180 degrees, and that's kind of where the triangle sum theorem comes from. If you draw a triangle and extend one side and then draw a parallel line to the extended side as shown, the sides form transversals, which you just learned in 7.2 what a transversal was, and those properties kind of yield the fact that if you rearrange those angles, they do form 180 degrees. And that's really the basis of the triangle sum theorem. So here's what the triangle sum theorem looks like. It simply states that the three angles of a triangle always add up to 180, because as we showed, you could cut the corners off and line them up and form a straight angle. Or algebraically, what that would look like is if you know a little something about some of these angles over here, you can kind of work backwards and solve them algebraically. So if you know a couple of the angles, you can always solve for the variable. And we'll look at some problems like that as well. So here's what you probably already know. You can classify a triangle by its angles, and obviously an acute triangle has all three acute angles. So all angles are under 90 degrees. A right triangle obviously has one right angle, so usually that's indicated by the little box that indicates the right triangle, the 90 degrees. An obtuse angle has one obtuse angle, so one angle that is above 90. So that's kind of should be a review for you. Let's move on to some more exciting things. Using the triangle sum theorem, we can kind of work backwards to solve for a variable if given two of the angles. So here, in this case, we are given two angles, 73 degrees and 44 degrees. And if we add 73, 44, and p, we know that that's going to equal 180 degrees. Adding 73 and 44 and trying to isolate the variable, solving this algebraically, we would get 117 plus p equals 180 degrees. So in order to get the variable by itself, which is always the name of the game, we simply subtract 117 and we find out that the missing angle is 63. And obviously you can always check your work by adding those three up and making sure they in fact add up to 180 degrees. Given this right triangle, we know that the box means 90 degrees. One of the other angles is 42, so now we can find C by simply adding 42 plus 90 plus C. We know that equals 180. Adding 42 and 90 together, we get 132, and then subtracting 132 from both sides, we can find that C actually equals 48 degrees. And again, we can check our answer by simply adding them back together and making sure that those three angles make 180 degrees. Find m degrees in the obtuse triangle. Well, since they say obtuse and neither of the angles that they've given us are obtuse, we know that m is going to be greater than 90, so we can already kind of make sense of our answer. And using the triangle sum theorem, we add 23 plus 62 plus m, and that should equal 180 degrees. So combining our like terms, which are our numbers, we would get 85 degrees plus m, and isolating the variable, which means subtracting 85 from each side, we would find out that m equals 95 degrees. And remember, we were expecting an obtuse triangle, so our answer makes sense. A few other terms that you probably remember from years past. Equilateral triangle obviously has three congruent sides. which is usually overlooked. We all know that it has three congruent angles, but remember, congruent angles create congruent sides, so it makes sense that the sides and the angles are all congruent. An isosceles has two congruent sides, which means it has two congruent angles, and a scalene triangle has no congruent sides and no congruent angles. And we can use those facts to help us solve triangle sum theorem problems. For instance, this one, since we know that all angles in a triangle add up to 180, we could also say that b plus b plus b equals 180, since those three those three angles add up to 180, and we know it's an equilateral, so it makes sense that each of those would equal each other. So we'll just call b plus b plus b 3b, and we'll solve it algebraically, which means isolate the variable, which means do the inverse operation. So we'll divide by 3 on both sides, and we'll find that b equals 60, which we probably already knew, but there's proof that it is the case. If they let us know it's an isosceles triangle, by definition, that means we have two congruent sides and two congruent angles. So again, using the triangle sum theorem, add t plus 62, or 2t plus 62 degrees, and that should equal 180. Solving this like our normal two-step equation, we would first get rid of the 62 by subtracting it from both sides to keep our equation equal. That leaves us with 2t equals 118 degrees, and to solve for t, we simply do the inverse operation, which means divide by 2, and we'll find out that t equals 59 degrees. And we can plug that in for both of our t's, add that to the 62, and verify that our answer is correct. Our last example involves a little bit more of an algebraic approach, or it's a little bit more algebraic than the previous ones. But we do treat it the same. We know that all three angles have to equal 180 degrees, so we simply do the same thing that we've been doing, and that is add them up and then kind of solve for our variable. So let's go ahead and do that. We know that 3x plus 5x plus 2x should equal 180. Combining like terms, we could call that 10x, because remember that 2x plus 3x plus 5 more x gives us 10x. Solving for x, we would divide both sides by 10, and we'd find out that x equals 18 degrees. But be careful, that doesn't mean each angle is going to be 18 degrees. It means that we now have x, so we can put it back into the numbers and multiply. For instance, 5x now becomes 5 times 18, and we can solve and figure out that angle, the angle measure of that. The same for 2x. We could plug in 18, do 2 times 18, we'd find out that angle's 36 degrees, and we could do the same for 3x. Plug in 18, 3 times 18 would be 54. So we can find each of our angles that way. We can verify by adding them up and see if they equal 180, and that would prove our point. Other than that, I think that pretty much does it for this lesson, 7-3 angle and triangles. So good luck with your homework.